In physics, a subatomic particle is a particle smaller than an atom. In schools, children are taught only 4 components of an atom, namely electrons, protons, neutrons, and nucleus. But except these, there are many more things about whom you must know about. This is a tale about the atomic family. According to the standard model of particle physics, a subatomic particle can be either a composite particle, which is composed of other particles, for example, a baryon, like a proton, or a neutron, composed of 3 quarks, or a meson, composed of 2 quarks, or an elementary particle, which is not composed of other particles, for example, quirks, or electrons, muons, and tau particles, which are called leptons. Particle physics and nuclear physics study these particles and how they interact. Most force-carrying particles like photons or gluons are called bosons and, although they have discrete quanta of energy, do not have rest mass or discrete diameters and are unlike the former particles that have rest mass and cannot overlap or combine, which are called fermions. Experiments show that light could behave like a stream of particles called photons, as well as exhibiting wave-like properties. This led to the concept of wave-particle duality to reflect that quantum-scale particles behave both like particles and like waves. They are sometimes called wavicles to reflect this. Another concept, the uncertainty principle, states that some of their properties taken together, such as their simultaneous position and momentum, cannot be measured exactly. The wave-particle duality has been shown to apply not only to photons but to more massive particles as well. Interactions of particles in the framework of quantum field theory are understood as creation and annihilation of quanta of corresponding fundamental interactions. This blends particle physics with field theory. Even among particle physicists, the exact definition of a particle has diverse descriptions. These professional attempts at the definition of a particle include: a particle is a collapsed wave function. A particle is a quantum excitation of a field. A particle is an irreducible representation of the Poincare group. A particle is an observed thing. They can be classified by composition, mass, statistics, and decay. Classification by composition. Subatomic particles are either elementary, not made of multiple other particles, or composite and made of more than one elementary particle bound together. The elementary particles of the standard model are 6 flavors of quarks: up, down, strange, charm, bottom, and top. 6 types of leptons: electron, electron neutrino, muon, muon neutrino, tau, tau neutrino. 12 gauge bosons, the photon of electromagnetism, the 3 W and Z bosons of the weak force, and the 8 gluons of the strong force. The Higgs boson. Hadrons. Nearly all composite particles contain multiple quarks bound together by gluons. Those containing few quarks, including antiquarks, are called hadrons. Due to a property known as color confinement, quarks are never found singly, but always occur in hadrons containing multiple quarks. Classification by mass. Any subatomic particle, like any particle in the 3-dimensional space that obeys the laws of quantum mechanics, can be either a boson or a fermion. In the standard model, all the elementary fermions have spin 1/2 and are divided into the quarks, which carry color charge and therefore feel the strong interaction, and the leptons, which do not. The elementary bosons comprise the gauge bosons with spin 1. While the Higgs boson is the only elementary particle with spin 0. The hypothetical graviton is required theoretically to have spin 2, but is not part of the standard model. Some extensions, such as supersymmetry, predict additional elementary particles with spin 3/2, but none have been discovered as of 2021. Due to the laws for spin of composite particles, the baryons have spin either 1/2 or 3/2 and are therefore fermions. The mesons have integer spin of either 0 or 1 and are therefore bosons. Classification by mass. In special relativity, the energy of a particle at rest equals its mass times the speed of light squared, E equals mc square. That is, mass can be expressed in terms of energy and vice versa. If a particle has a frame of reference in which it lies at rest, then it has a positive rest mass and is referred to as massive. All composite particles are massive. Baryons tend to have greater mass than mesons, which in turn tend to be heavier than lepton. But the heaviest lepton, the tau particle, is heavier than the two lightest flavors of baryons. It is also certain that any particle with an electric charge is massive. All massless particles are elementary. These include the photon and gluon, although the latter cannot be isolated. Composition by decay. Most subatomic particles are not stable. All leptons, as well as baryons, decay by either the strong force or weak force, except for the proton. Protons are not known to decay, although whether they are truly stable is unknown. Neutrinos and antineutrinos do not decay, but a related phenomenon of neutrino oscillations is thought to exist even in vacuums. The electron and its antiparticle, the positron, are theoretically stable due to charge conservation, unless a lighter particle having magnitude of electric charge exists. Through the work of Albert Einstein, Satyendranath Bose, Louis de Broglie, and many others, current scientific theory holds that all particles also have a wave nature. This has been verified not only for elementary particles, but also for compound particles like atoms and even molecules. In fact, according to traditional formulations of non-relativistic quantum mechanics, wave-particle duality applies to all objects, even macroscopic ones, although the wave properties of macroscopic objects cannot be detected due to their small wavelengths. That's all for today. See you in another video.